Over the past decade, electronic waste around the world has grown by at least 60%. So, unwanted tech piles up on the curb, waiting for treasure hunters to find it. The materials inside the electronics thrown out every year are worth an estimated $60 billion. Scrapping doesn't really pay off until you can invest in heavy-duty equipment that can cost tens of thousands of dollars.
When you put it on one of our shaker tables, the metals go one way and the waste goes another way.
Jason Gaber comes from the world of underground mining, but now he sells crushers that can be used for e-waste.
E-waste is going to be the richest ore of the future.
Today, only about 9% of e-waste in Australia is formally collected. The US is only slightly better at 15%. Last year, Americans consumed more than 6 billion avocados, and that produces a lot of inedible waste. Now, a company has developed a process to transform avocado pits into plastic. Bioplastics like these could help reduce pollution because they break down faster and use less fossil fuels. We visited Biofase in Monterrey, Mexico, to see how it all works. Mexico exports about half of the world's avocados. The process starts with avocado seeds that have been washed at the supplying factory. As the seed is going through the machine, it's turned into a bioplastic resin that's ready to withstand a lot of heat. What comes out the other end is a malleable sheet that can be molded and cut into different shapes.
This oil painting is worth a lot of money because it's actually a gigantic oil spill. Gross. But not to worry, it can still be picked up and salvaged with a special kind of sponge. No, not that sponge. No matter what your take on fossil fuels or renewable energy is, I think we can all agree that oil spills are not great. And we need a better way to clean them up. Right now, we mainly just set them on fire. Yeah, just burning the ocean.
It's called an in situ burn. You get it so it's thick enough on top of the water that you can strike a flame and it'll actually just burn away.
But what if you could pull that oil out and use it? And what if we all might be sitting on the solution?
The starting material I'm actually probably sitting on right now. It's polyurethane foam.
It turns out this super common material with a few atomic modifications can clean up oil spills better than anything else we've got. Which is good because we spill a lot of oil. A few 100 million gallons every year.
The big ones happen once in a while and they make front page news. But there are actually thousands of oil spills every year just in the United States.
A new wave of material sciences could help us start cleaning the environment instead of just, well, using it as a trash can. This is Hard Reset, a series about rebuilding our world from scratch. Everyone hold on to your butts. Hey, it looks like someone was filming while I was monologuing. That's me. So just like the United States has a network of national parks, it also has a network of national laboratories where incredibly advanced research can be done that isn't quite feasible for industry to carry out. The most famous national laboratory, Hawkins National Laboratory, where they help orphans find their true talents, apparently isn't even real. I know, I'm disappointed too. It was probably loosely based on this place, Argonne National Laboratory, which was built in the woods, totally normal, and has these very not weird buildings that are definitely not housing gates to other dimensions or demogorgons.
Science builds on itself. You're always standing on the shoulders of giants, but a stack of giants.
This is Seth Darling. Seth helped create a new oil-loving sponge from an everyday material.
Everybody interacts with polyurethane foam all the time. It's used in furniture cushions, insulation, and other things. Super cheap, made on a huge scale. It would be great if you could just take polyurethane foam and have it soak up oil. But unfortunately, polyurethane doesn't like oil more than water. In fact, it likes them almost exactly the same.
But what if you could change the surface properties of polyurethane by applying a super thin layer of some other material? Like 4 billionths of an inch thin. Jeff knows all about that.
The research that I do is ways to put down single atomic layers that can make a profound impact on society. And in this case, it's the ability to clean oil from seawater. The particular technology that we do, this atomic layer deposition, is able to put single atomic layers on the outside surfaces of materials and change their functionality. That's what we did for oleosponge.
The idea is that if you can lay down a single layer of atoms or molecules, you can totally change how an object interacts with the world around it. For example, you can make something hydrophobic, so water rolls right off of it. Or you can make it oleophilic, so oils cling to it.
So we start with polyurethane foam, and then we do a two-step process to it to change its surface chemistry.
First, they coat the entire interior surface of the foam with molecules that have aluminum or zinc in them. This makes it easier for another layer of molecules to be applied on top. The second step is to apply that layer of molecules, called a silane.
That one end of the silane molecule binds very strongly to those metals. The other end of the silane molecule was chosen to love oil.
Let's go to the next lab.
So how do you add these teeny tiny layers? Well, in this teeny tiny reactor. It's real small. Like a pipe. It's a pipe.
So let's open the reactor. So now we'll load bunch of polyurethane foam. This is very quick, just 10-minute job to coat 1 nanometer.
Inside this pipe, reactor, the temperature and pressure are controlled with incredible precision while the chemical vapor is inserted.
So now when we take that sponge and we put it down into oil and water, it doesn't grab any water because it's hydrophobic, but it grabs oil voraciously. That's why we call it oleophilic, oil-loving.
Yeah.
It loves the oil.
And once you've got an oil-loving sponge, you can get started cleaning up the world, right? Well, almost.
We've had a lot of interest from companies asking us, this sounds great, can you send us 50 square meters? And we say, sorry, we can't do that right now. We can send you a 1-inch cube, or if you give us time, we'll send you a lot of 1-inch cubes. But that's the bottleneck, is the scale up of the manufacturing.
Sounds like you need a bigger pipe.
Yeah.
Remember in Superman 3 when Superman literally blew oil right back into a tanker? Neither do I. But it might actually not have been the most unrealistic thing about this movie.
The mindset with oil spills today is let's just try and get it out of the environment. And it's sort of already assumed to be a loss. Oleosponge is a hard reset for oil spill cleanup. It's a lot more sustainable and makes a lot more sense than burning the oil, which is the dominant technique that's used today.
Other ways of cleaning up oil from the ocean will put that problem somewhere else. They'll either convert it into CO2 so that it causes global warming, or they'll end up stuffing a landfill.
But just like Superman, oleosponge has the potential to grab all that oil and put it right back into a tanker. It just needs to scale up a bit.
There's a big gap between a 1-inch cube and addressing a spill in the open ocean. So we've taken some steps towards scaling it up. There's a big facility in New Jersey called OMSET. It's a gigantic tank so they can actually spill oil into seawater, but not in the open ocean, and train people on how to clean it up. And it's also used to test new oil spill technologies like oleosponge.
The oleosponge team made 10,000 little cubes and sewed them together. And with these, they were able to test this technology on a large scale. Most oil removal technology is limited to the surface, but oleosponge can be dragged under the water to clean up below the surface.
That was actually our main goal in developing oleosponge. It works great on slicks on the surface, and we hope it'll be used for that. But we really wanted to solve this challenge for which there is no solution today, oil in the water column. We weren't sure it would work, but it actually did amazingly well. It was the first successful demonstration of pulling oil out of the water column like that. When they did the chemical analysis, it worked with different crude oils and even with diesel fuel, which also gets spilled into water a lot. That's a refined oil product.
The oleosponge pulls oil out of the water, but it can also be wrung out again and again and again. The other big difference is that the recovered oil can actually be used instead of just, burning it.
You recover the oil, you reuse the sorbent. It's just a completely different way of attacking an oil spill.
So picture a scenario where a ship drags a net of these sponges behind it, wringing out the sponges and recirculating them as it goes. A single boat like this could pull tons and tons of oil out of the ocean. That oil wouldn't be a waste product, it would be a usable commodity. You could sell it and refine it into all the wonderful things we typically pollute our environment with, like plastic and gasoline. But this isn't just a hard reset for cleaning up oil spills. it could also have huge implications for every aspect of how humans use water.
Using our innovation in material science and materials chemistry to tackle water challenges is really a revolution in how we think about water, which is to close the loop. Instead of going once through, you take water out of the environment, you clean it if you need to, you use it, but now instead of dumping it back into nature again, you clean it up enough and reuse it.
If we could clean up our wastewater to the point where we didn't need to take as much out of the environment to survive, we wouldn't need to deplete the groundwater that has taken tens of thousands of years to accumulate, or take water out of the rivers and lakes that have replenished those sources. But first, we need this technology to be widely available.
We need somebody to take this technology, make the tools that someone can then buy to manufacture it, to sell to all of these people who are lined up down the block ready to buy it.
You can't help but think, gosh, if only there was some giant industry with lots of money and power and a global logistics network that might contribute to oil spills in some way. Oh well, seems unlikely. But then again, it also seemed unlikely that Superman 3 would be an accurate prediction of the future. Come back next time for another episode of Hard Reset. Subscribe to Freethink to watch our other original series and documentaries about technology and people that are changing our world.